I'm holding a glass of water and I'm putting a straw inside it. What do you observe? The straw appears slightly bent in water. This phenomenon is called refraction. In this figure, there is an incident light coming from the air. It is moving towards another medium, glass. Some of the light will be reflected and some will enter into the glass. This light which enters the glass is refracted ray. You can observe that it is slightly bent. This phenomenon of bending of light is refraction. So let's define refraction. The bending of light as it passes from one transparent medium to another transparent medium is called refraction. There will be change in speed of light as it enters the denser medium, which is glass. The light will slow down, and this change in speed causes refraction. Now what happens to a ray of light which travels from a rarer medium to a denser medium? Let's say it travels from air to glass. Here is the incident ray. Some part of it will get reflected and some part will enter into the glass as the refracted ray. Line MN is the normal. You can see the dividing line. This is the line which divides the first and the second medium. I is the angle of incidence. This is the angle made by the incident ray with respect to the normal. Angle R is the angle of refraction. This is the angle made by the refracted ray with respect to the normal. Now, in absence of the medium, you can imagine that the incident ray would have travelled in an undeviated manner. It would have gone straight. But because of the medium, there was some deviation. We will represent this deviation as delta. Now, the angle of incidence is greater than the angle of refraction in this case. Deviation delta is equal to I minus R. Angle I is greater than angle R, right? So, when light travels from a rarer medium to denser medium, the refracted ray is bending towards the normal. And therefore, the angle of incidence is greater than the angle of refraction. And deviation delta is equal to I minus R. Now what happens to a ray of light which travels from a denser medium to a rarer medium? Let's say it is traveling from the glass to the air. Here is the incident ray. Some part will get reflected and some will enter the air. So you can see that the refracted ray is bent with respect to the normal. Again, I is the angle of incidence, R is the angle of refraction, and delta is the deviation of the refracted ray. You can observe here that the angle of refraction is greater than angle of incidence, and deviation delta will be equal to R minus I. So when a light ray travels from a denser medium to a rarer medium, the light ray, the refracted ray, tends to move away from the normal. So delta will be equal to R minus I. You can see here that the incident ray is coinciding with the normal. Angle I is equal to 0 and angle R will also be equal to 0. In this case, there is no deviation from the original path. Delta is also equal to 0. What is the cause of refraction? When the light ray travels from one medium to another medium, there is change in speed of light, and this causes refraction. We saw that when light travels from a rarer medium to a denser medium, the refracted ray moves towards the normal. And when the light ray travels from a denser medium to a rarer medium, the refracted ray moves away from the normal. In the first case, when the light moves towards a denser medium, its speed decreases. When light moves to a rarer medium, the speed will increase. So this change in speed of light as it moves from one transparent medium to another transparent medium is the principal cause of refraction.